there! Here we have a problem about sketching the graph of a logarithmic function. The directions state, sketch the graph of the following function and state its domain and range. The first part of the problem said list ordered pairs that satisfy the function. This has already been done. We're just going to focus on how to graph this here on MathXL. So if you look right here where it says click to enlarge graph, we're going to click inside this box to sketch this graph. So let's click in there. Okay, there is a graph already here, but this graph does not go through the point 6, 0, which is the x-intercept. So we're going to clear this graph. So I'm going to click here where it says clear. This will clear all objects drawn on your graph. Are you sure you want to continue? Okay. Now we're going to go over here. There's two curves here. There's one that says logarithm tool, and there's one that says exponential tool. Since this is a logarithmic function, we're going to choose the first one that says logarithm tool. Let's click on that. Alright, now that that is selected, let's make sure we have the correct line here. It can either be solid or dashed. We want to make sure our object is solid, and that's already selected for us. Alright, let's go ahead and click anywhere inside the graph. It gives us this basic logarithmic function with a base of e. We want a base of 10. If you can recall, let me see if I can move this over so we can see the logarithmic function here in the back. So since there is no base written here, this is a common log, and then that means that our base is 10. So where it says base, I'm going to click in there, I'm going to backspace, and I'm going to type in 10 for the base. Alright, reflecting over the x-axis. It is being reflected over the x-axis because if we look at the front of the logarithm, there is a negative in the very front. And whenever you multiply the very front of a function by a negative, you are reflecting that basic function across the x-axis. So we're going to click on reflect over x-axis. Alright, next part. The 1/4. The 1/4 that's being multiplied in front of the log, this is going to represent a vertical shrink. So we're going to go where it says vertical shrink. In here, we're going to type in 1/4. So I'm going to go 1/4. Enter. Alright, there is no horizontal stretch because we don't have a coefficient in front of the x. The x has a coefficient of 1, so we're just going to leave that as a 1. The vertical shift, there is no vertical shift because there is nothing being added or subtracted after the logarithm. There is a horizontal shift. If we look inside of the logarithm, it says x minus 5. So that means there's going to be a horizontal shift of 5 units, right, towards the positive direction. So it's a positive 5. And I believe we have everything in there correctly now. So let's go ahead and close this box. If we look at our graph, this looks like it goes through the x-intercept of 6, 0. Good. So let me close my box here. Let's click on the Save button. Our graph is right here. Now let's click on Check Answer. It says fantastic. Okay. The domain of the function. So the domain of the function, if we were to look inside of this parentheses inside here the logarithm where it says x minus 5, it's necessary to only have positive numbers inside of a logarithm. We can't have 0 and we can't have negative numbers. So we would need to take x minus 5 and set it greater than, strictly greater than 0. So if I were to do that, x minus 5 greater than 0 and then solve for x, I would get x needs to be greater than 5. So another way to write that would be the open interval from 5 to infinity. All right, let's check that. Good, nice work. And the last part, the range of the function. The range of the function are going to be all the values of y that we can get from here. And if you notice, this goes up towards positive y, positive infinity. And this, even though it looks like it lines up here with the x-axis, it actually goes downward. So it can actually go down towards negative infinity. So the range for this function is going to be all real numbers. Or another way to write that would be the open interval from negative infinity to positive infinity. Let's check that. Well done. Okay. Good. And that's it. The question is complete. We've answered all the parts, and there's our graph. Okay, hope that helps.